I don't think projectile motion is as bad as I've made it sound in all that typing. It's just a cool application of perspectives like we did in relative motion and the equations that we just sort of wrapped up in the last topic. I've typed on your virtual note sort of the steps to solving a problem. We're just going to work it through. Basically, we're going to sketch it or draw it, label the numbers. We want to find the question mark. And then what's weird is we're going to start with the other component. A little bit messy. Define time. Once we got time, then we can solve. It's all about perspective, so when we work through this first one, I'll kind of talk you through the perspective while following those steps. So a ball is thrown horizontally at a speed of 5. So a little tennis ball here. It's going sideways at 5. It says it was thrown from a height of 1.8. So the 1.8 fits in here. The ball is going to follow a nice parabola, crash into the ground somewhere over here. When we ask where does it land, the where does it land always, it's always a horizontal distance. Not some sort of weird Pythagorean theorem from where the ball started to where it landed, just that horizontal distance in front. The numbers that were given, we're needed to find the numbers. We've got the horizontal velocity of 5, and then this vertical distance of 1.8. The unknown is horizontal. I don't know how far forward it goes. So because I don't know how far forward, I'm going to start with the vertical. There's enough in the vertical that I can figure some stuff out. I'll squish it in down here. In the vertical, I know that it falls 1.8 meters. I know that gravity pulls it down at a rate of 9.8 meters per second. The other thing I know is the V1. And this is where the perspective comes into play. If we had a camera way over here, maybe this is supposed to be like a sideways eyeball. If your eyeball was way over here and you were watching this tennis ball go flying, the first split second the tennis ball was released, it might be tough to figure out when it was released because it doesn't really start falling right away. Kind of like cartoon physics. The first split second somebody runs off the edge of a cliff, they hover there before they fall. In terms of our tennis ball, the first split second it leaves the person's hand, it doesn't start to fall yet. So for that first split second before gravity gets a hold of it, we can say that its first speed is 0. Then gravity is going to accelerate at 9.8 as it falls for those 1.8 meters. There's enough there that we can solve for time. In projectile motion, we don't care about V2, so we often use the same equation, the no V2 equation. Because that V1 was 0, this whole first term drops to 0, so the math isn't too bad. We're going to say 1.8 equals 1/2 of 9.8 of t squared. I've done the math on my calculator. I'll let you crunch it out, but you should agree that time is 0.61 is what I got when I rounded it off. In our steps to solve, we started with the other component, we found time, now we're literally left to solving it. Where does the ball land? If we switch perspective now, if we were like a drone way high above it, it's not going to look good in the diagram, but if your eyeball was like way up here somewhere, looking down on it, so that's the sideways view of an eyeball looking down, terrible sideways view, but let's pretend that's an eyeball looking down, you might lose track of the fact that the ball's falling away from you. Like the ball would get smaller because it's getting farther away from you, but you definitely see it moving across the ground or across your screen at a rate of 5 meters per second. So in the horizontal, really what we've just figured out is that it moved 5 meters per second across the ground for a time of 0.61 seconds. I want to know how far it goes. Because it's not accelerating, we just have that simple equation. We could have done this one at the start of the quadmester. distance is always speed multiplied by time. Plugging in the numbers we got, 5 times 0.61, we're going to be really close to 3. When I did it on my calculator, I got 3.05. So the ball lands 3.05 meters in front of where it was thrown.